So first let us understand what is the requirement in this problem. We need equation of a plane containing a given line x minus 1 by 2 equal to y minus 2 by 3 equal to z plus 1 by 4, and that required plane should be perpendicular to the another plane which is containing two given lines, right? Now if you observe the equation of plane containing one line, so we are known a line on the required plane, but how is the plane? That plane should be perpendicular to another plane which contains two lines. So first let us find the equation of that plane which contains these two lines. Let A, B, C be the drs of normal to the plane containing, let's call these two lines, that is x by 1 equal to y by 3 equal to z by 2, and the other line x plus 1 by minus 1 equal to y minus 2 by 3 equal to z plus 1 by minus 2. Now, as this normal is perpendicular to every line that is on the plane, these ABC line, the line with the drs ABC, should be perpendicular to the first line. So when is it possible? We have A into 1 plus B into 3 plus C into 2 should be equal to 0. Let's treat this as equation 1. Not only this normal having drs ABC should also be perpendicular to the second line which is on the plane having drs as minus 1, 3 and minus 2. So when is that possible? A times minus 1 plus B times 3 plus C times minus 2 is also 0, right? Now 1 and 2 are two simultaneous equations in terms of A, B and C. So can we solve these two to get a proportionate values of A, B, C? Yes, what do you get? We get A by 2 equal to B by 0 equal to C by minus 1. So we got the drs of normal to the plane which is containing the last two lines given. So can we write the equation of the required plane now? As we know that as the required plane is containing the given line which is x minus 1 by 2 equal to y minus 2 by 3 equal to z plus 1 by 4. When do we say a plane contains a line? Yes, every point on the line must be a point on the required plane. And if you observe here, 1, 2 and minus 1 is already a point on the line. That means even the required plane is also passing through that point. So the possible equation of the required plane will be in the form alpha times x minus 1 plus beta times y minus 2 plus gamma times z plus 1 equal to 0, where alpha, beta and gamma will be the drs of normal to this plane. Let's call this equation 3. We have to find the values of suitable alpha, beta and gamma so that we get the equation 3, right? Now how is this plane? This plane is already containing the given line. That means this normal having drs where alpha, beta, gamma denotes what? Are the drs of normal to the required plane. And the problem is to find the values of alpha, beta and gamma only. But what are the conditions to get the value of alpha, beta and gamma? Yes, first condition is this line is lying on the plane. That means alpha, beta, gamma drs line must be perpendicular to the line with having drs 2, 3 and 4. As normal of the plane is perpendicular to the line having x minus 1 by 2 equal to y minus 2 by 3 equal to z plus 1 by 4. When is this possible? Alpha into 2 plus beta into 3 plus gamma into 4 should be equal to 0. Let's call this as an equation 1. Now in order to get the second equation for alpha, beta and gamma, now to get another condition in alpha and beta, let us use the condition that as the required plane given by third equation is perpendicular to the plane with normal drs 2, 0 and minus 1. That is the plane which is having 2, 0 and minus 1. The first plane which is containing both the lines. Now when do we say this plane is perpendicular to the other plane? Yes, the normal should be mutually perpendicular. So alpha into 2 plus beta into 0 plus gamma into minus 1 is 0. This is another condition in terms of alpha and beta. Now using the first and second equations on the alpha by 0 plus 3 equal to beta by minus 2 minus 8 equal to gamma by 6 minus 0, that gives us alpha by 3 equal to beta by minus 10 equal to gamma by 6. So we got the values of dr proportional to 3, minus 10 and 6. So can we complete the equation now? The equation of the required plane 3 times x minus 1 gamma minus 10 times y minus 2 plus 6 times z plus 1 equal to 0, or in simplified form it is 3x minus 10y plus 6z. How much is the constant? Minus 3 plus 20 plus 6 plus 23 equal to 0. Let's identify the suitable option. 3x minus 10y plus 6z plus 23 equal to 0 is the option presented. B is the required plane which contains the given line and perpendicular to the another plane which is containing two given lines, right?